All right, let's have some fun. I'm going to show you guys a really cool trick that you can use if you want to add together fractions with different denominators, unlike denominators. And here's an example where these three things that I have written here, the 56xyz and 48xyz and 30xy, let's pretend like each of these is the denominator in a fraction that you'd like to add together. So there's three fractions, you want to add them together, you need a common denominator. So we're going to find the least common denominator. Here's how we're going to do it. This method I call backwards shopping. So usually when you go shopping, you're looking for a discount or a bargain, right? Well, today what we're going to do is we're going to pretend like we're super rich and we want to rub it in other people's faces. And so what we're going to do is we're going to pick out the most expensive stuff we can find. And we're going to pretend like each of these denominators is a store. Maybe the first one is like maybe Nordstrom's, and the second one is maybe like Macy's, and the third one is, I don't know, Kohl's. And maybe you don't like my choice of store names, I apologize, but please bear with me. So what we're going to say next is we're going to pick stuff out. Well, first of all, before we begin, we have to have everything written down as prime factors. So the very first thing we'll do is we'll go ahead and we'll break the 56 down into its prime factors. So 56, make the factor tree and start dividing. That'll be, I think it's 28 divided by 2. Let's see here. And then that gets us 14, divide by 2, and then that gets us 7. So there we go. So 56 is really going to be 2 to the third power times 7. And then we'll keep writing x cubed y z squared. And then we'll do the same thing for 48. And 48, if we divide by, let's start by dividing by 3. We then get 16. We then divide by 2, we then get 8. Divide by 2, we get 4. Divide by 2, we get 2. We now have 2 to the fourth power times 3. And then x, y cubed, z. And then finally 30. Let's find the prime factors. So divide by 3, we get 10. Divide by 2, we get 5. So 2 times 3 times 5 times x squared times y. Now let's take a look and see why we did all this madness. And we do need to do this every time. Hopefully our normal situation won't be this complicated. Here's what we're going to do. We're going to do backward shopping. See how Nordstrom's has a 2 to the third power, and Macy's has a 2 to the fourth power, and Kohl's has a 2 to the first power? We want the most expensive 2 we can get, and Macy's has it. It's the fourth power. So in our LCD, we're going to start collecting the most expensive of each item that are at all the stores. So there's a 2 to the fourth power. Now, we no longer need to worry about 2's. We can cross it off our shopping list. They're gone. Next, here we have 7. We're going to not worry about that right this second. Here we have 3 to the first power and 3 to the first power. So we're going to go ahead and throw 1 3 to the first power because the most we can get it either at Macy's or Kohl's. It doesn't matter, but we buy the most expensive 3 we can get, and once we've bought it at one store, we don't need to buy it at the other store. Next, we've got a 5 to the first power and no 5 and no 5. So we're going to go and throw a 5 into our LCD and cross it off. And then we've got a 7 to the first power and no 7 and no 7. Most expensive 7, Nordstrom's, 7 to the first power. We throw it in there. And then x cubed, x, and x squared. The most expensive x can be found at Nordstrom's. It's x to the third power. And then y cubed, y. Most expensive y is y to the third power. And then we've got z squared, and z to the first power, and no z. Most expensive z is at Nordstrom's, and we'll go ahead and we'll buy it. That's z squared. Oops, I forgot to cross off the y's. We already got ourselves a y to the third, and that was the best. X cubed we can cross off, and now we've done it. We've got everything we need for our LCD. The only thing is we'll simplify by multiplying those numbers together. Okay, and so when we multiply them all together, we get 1,680. And we still have our x cubed, our y cubed, and our z squared. So our final answer will be the LCD is this. And we could then use that LCD to add together fractions that, that will now have a common denominator of this. Now, there's more stuff we have to do to those fractions, but this is a good method for finding the LCD for a bunch of fractions with complicated denominators. Now, I do want to show you one more thing. All right, so here's another set of denominators, and again, these look pretty complicated. The way that we'll find the least common denominator is, again, just like we did before, we're going to have to find our prime factors. So before, when we found our prime factors, it was more straightforward. Here, in order to factor, I'm going to try to remind you of some things. For example, x squared minus 10x plus 25. I'm hopeful that you recognize this as a perfect square trinomial. And if you do, you can go directly to the idea that this is going to be x minus 5 squared, okay, or x minus 5 times x minus 5, and it'll still be times x cubed. And then this guy, x squared minus 25, I hope you recognize how to factor that guy. That should be x plus 5 times x minus 5. Or x minus 5 times x plus 5. Either way, it's just fine. And then here, this one is one I talked a little bit about, but I want to make sure that we get some practice in it. I can factor out a -1, and then this 5 minus x will look a lot more like this x minus 5 that we have here and here. So I'm going to go ahead and factor out a -1, and then we've got x squared, and then we've got x minus 5. Now, I kind of had to factor out that -1 because if I don't, then I would have to include 5 minus x in my least common denominator along with x minus 5. They would be considered two different prime factors. But by factoring out the -1, now all I have to do is include -1 in my LCD, in addition to the x minus 5 from these guys. Okay, so now we're going to go shopping. We're going to use the backward shopping method. We're going to take the most expensive of all the prime factors from all the stores. Again, Nordstrom's, Macy's, and Kohl's. So -1, I don't see any other -1s, so we're going to go ahead and include a -1 in my LCD. And then times x squared, no x squareds, x to the third power right over here. We're going to include the x to the third from Kohl's in our LCD, and we can go ahead and get rid of the -1 and get rid of the x squared and the x cubed. And then we'll go back and go shopping. I've got an x minus 5 to the first power, and an x minus 5 to the first power, and an x minus 5 to the second power. I'm going to go ahead and throw that x minus 5 to the second power into my LCD, and then I can get rid of all my x minus 5s. Because I bought the most expensive one at Kohl's, I don't need to buy it at Macy's or at Nordstrom's. And then finally x plus 5 to the first power. Now again, these examples that I'm giving to you are quite a bit extreme, just so that you can see how powerful this technique is, even when you have rather complicated denominators in your fractions. And again, it doesn't matter how many you have, you can use this technique.